In this lesson we introduce more advanced tools for regression models with R. In particular, we will see how to perform model selection, using the so-called ICAIC Information Criterion AIC. The data for the first example are available in the file prostate.txt, which can be imported as seen in the previous lesson. First, a quick recap of what told about the topic. Machine learning and prediction models have as their main purpose that of interpretability, that is, the minimization of the prediction error. However, too complex models pay a price in terms of explainability. The more a model is complex, the less it is explicable. Therefore, there is a trade-off between interpretability and explainability. As an example, the text file to use includes data on 97 men with prostate cancer who were going to receive a radical prostatectomy. The outcome variable is called LPSA and represents the prostate-specific antigen, measured in log scale. Additionally, further patient-specific clinical information is available. The data can be read using the command read.table, prostate.txt. The idea of the ICAIC Information Criterion AIC is to simplify the model by omitting useless predictors. Indeed, the AIC selects the subset of input variables that keep explainability, low prediction error. While improving interpretability, prefer simpler models with less variables. An input predictor is included if it increases explainability. Otherwise, it is not needed. The library mass must be loaded for such operations. We divide the data in training and test set to apply the regression and the AIC only to the first subset. First of all, we fit a linear regression and save the output in a variable named full model. We already saw the LM function. We use in this slide the dot syntax to specify that all variables available are used as predictors. Then the AIC can be easily run by calling the function step AIC and passing as parameter the object that contains the outcomes. That is named full model. We also need to specify that we only want to work with data in the training set, hence we write data equal to training set. The final option, trace equal to 0, is just for convenience to suppress a detailed output. If we inspect the output, we see that 3 variables have been selected, since the others are not even shown. You have to repeat what reported in the previous slides with the given data, to run a linear regression with AIC. Data are taken from a real medical study, whose goal is to study the Stes-Streck curve of the aorta based on patient-specific clinical variables. Data are contained in the files input.txt and output.txt from the compressed folder we provided you. This is the list of the input patient's characteristics. In the slide you can see the goal of the exercise.